Okay, hi everyone. We are continuing our discussion about multicomputation and programming around multicomputation. And I think Nick has, let's see, do I need to, I run this initialization cell here?
Yep. So this is just basically a few new properties and options that are added to the multi-object.
Nick, what's this?
I've never seen that before.
Oh.
Well, what version are you using? I'm still running all my code on 13.1. Yeah, this one.
All right, let me try quitting this.
Yeah.
I want to take it a little bit from the top here of, here, let's just make sure this works. Oh, what the heck is this?
Well, is it working? Maybe just a cautionary message or something. It still loads, so.
Well, let's try it.
Yeah, just the old version. Yeah.
Well, oh dear. I wish we'd tried this. I mean, I don't understand it. Can I do packlet uninstall of this?
Yeah, let's try this. I also re-uploaded the package just in case.
Well, what is this? It says it isn't found.
Well,
So
you probably need to say multi-computation or something. Wolfram /
yeah,
multi-computation.
you have to specify the name. Wolfram / multicomputation, not the link.
in a string.
Yeah.
Yes.
Slash.
Okay. Now let's try installing this. Okay, what is in what is this? Is that
This is just
why don't we not use the short URL? Just give me the full URL.
Or can you try the actual name the way you uninstalled it?
Well, here I've got this.
You already went past the install line. Yeah.
Oh, it's the same link.
Yeah, it's the same install thing.
You can try the same string to install it from the repository.
This one here.
No, I mean Wolfram / multicomputation. Just install it with the name, not the link.
Well,
That's weird.
what's going on?
It's definitely there.
Well, how do I know what packlet sites I'm looking at?
Packlet sites open close.
That the right place?
There's the two default ones.
Well, what the heck's going on? I mean, I can find it here, or I don't know whether that, what happens if I just try and install. Oh, I see. It's got to be the packlet. Oh, sigh. Come on. We should be able to deal with this. Is verified packlet to get more information. Okay, Nick, are you figuring out a solution, or are we stuck here? And why does it say verified packlet function if it doesn't exist? Why does it say that here? Tracy, that's for you to track down. That shouldn't say that if the function doesn't exist.
I've noted it.
Okay. Okay, Nick, what do we do here? We give up on me demoing stuff and you have to do it on your machine? I'm not happy with that.
Oh, my machine also problematic. For some reason, I can't even upload the packlet again. Maybe it's something actually in the cloud.
Or
Something
the
with the cloud.
packlet. Or okay, so Tracy, could you try and reach out to whoever is relevant to figure out if there's something, maybe Todd or somebody.
Sure, can do.
All right, but let's take a look then. I don't understand so let me just review, and particularly since Jonathan is here and hasn't seen a lot of this stuff, I just want to review kind of what the basic design is. And then we're going to be, let me just look at your, the stuff you sent pre-evaluated, okay? So let me just review. So basically the idea is, what's this function hypergraph multi? I don't think we have a bunch of different functions like that. I'm confused.
This is the one that creates multi-object, compiling everything to hypergraphs.
I see. So, and by compiling everything, how does it compile a general expression thing to hypergraphs?
You just compile it. You basically treat the links, the first element or the first vertex in each hyperedge as a link to every next sub-expression. So if you have a tree with children, then your hyperedge would contain as much links as their children. Also, in addition to the payload and its own link.
Mm-hmm.
So that's how it can compile the arbitrary tree, and therefore it can compile an arbitrary expression in the same way.
Okay, but it doesn't have the semantics of it is just doing a structural compilation. Is that correct?
Yeah, sure. Because as soon as you evaluate the right-hand side, you lose all the causal information. It would be hard to retrieve it from there. So it's also only structural.
But so the main thing you're doing with this hypergraphic compilation is, in a hypergraph, causality is very well defined by, this hyperedge is eaten, is destroyed here, et cetera, et cetera, et cetera. You're using this as a way to make sure to keep track of causal information. Is that correct?
Yeah.
I'm wondering if Jonathan has any particular comment on that.
Was there a question? I don't know. I mean,
well, no. The point is, for general objects, okay, it isn't necessarily defined, and this is an issue that you had in some of your multi-way X functions of just what is the thing that is the element whose causal information will be tracked, so to speak.
Well, I mean, okay, first of all, one has to be very clear on what one means by causal information, right? There are many different notions of causality that you can equip a graph rewriting system with, which are more or less expressive. We've tended to use, sorry, I should say this in the past tense. We did tend to use a very particular one in the context of the physics project. But that has a bunch of limitations, as we've discussed, like the fact that an event that sort of just touches an edge but doesn't actually manipulate it will still show up as being kind of causally related to other events that make use of that edge. So, I mean, what exactly do we mean by causality here?
Well, I know that's why I was asking you to join the conversation here, because what Nick is doing is he is transforming anything that is being consumed into hypergraphs, at which point he then has a well-defined definition of causality.
Right. So Nick, what is the definition? What is your definition of causality for hypergraphs?
Well, it's the same as the Wolfram model causality definition.
Okay.
Which is just using hyperedges.
Right. So if the output for one event makes use of hyperedges that were produced in the output of another event.
Yep.
Okay.
Right. Even if they were identity transformations.
Yes, or identity up to sub-hypergraph isomorphism or whatever. And in particular, also doesn't encode the kind of the dual notion of inhibition causality.
which you invented, right, Jonathan? Is that true, or is that?
Well, no idea is truly new, right? I mean, these things are similar notions have been discussed in the context of things like Petri nets and sigma nets and things. I don't think it had been discussed in the context of arbitrary rewriting systems before.
Okay, but just to review that, okay, what you mean by that is this is an edge which says, instead of an edge which enables something to happen by virtue of, yes, this function has its input ready, you're saying this inhibitory edge says, if this is produced, this function cannot happen.
Right. Right.
Which is something Nick is certainly not. Now, in the context of hypergraphs, is it obvious how to do that? Is that obvious? I mean,
that would be like, imagine I would create some additional option for the multi-replace when instead of replacing tuples and subsets, having rules on those, they also take elements that inhibit stuff, right?
Is that essentially an accept, or is it something different?
Well, yeah, it can be parameterized by accept, but maybe in a different way. The only point that the rule or its output would have a key that this particular hyperedge was inhibition hyperedge, and I can use this information to create in my causal graphs and events there.
Right, but you're saying that the event that takes place, the thing that we're assuming, that you're assuming in the hypergraph world, is that events pick up a subset. You've got a big vat of hyperedges, and an event picks up some subset, some tuple of hyperedges, and transforms them into some other tuple of hyperedges. So what you're saying is there can be a poisonous thing in the vat, which, how exactly would that work? Where there's a hyperedge, how would that work? Sorry, I don't quite understand how that inhibition thing works in that context.
Well, if you have an element with literal accept in your list of left-hand side hyperedges, right?
Mm-hmm.
It means you can't create an event, but in usual sense. But in this case, you actually create one, a special kind of event, and maybe with some dummy output.
Okay, but Jonathan, do you have a different way of understanding what, in the vat of hyperedges, what an inhibitory hyperedge looks like?
I mean, that could work, but it places the burden on the user, right, to be able to specify that. You could easily specify an inconsistent version of that.
You mean with inhibition and non-inhibition?
Yeah.
Okay, well, what's a different way to do it?
The point is the reason for choosing, Nick choosing this, the sort of physics project notion of causality is a very sensible decision because it's the version of causality that's relatively easy to determine, right? There's a well-defined finite deterministic algorithm that can determine whether whether two events are causally related. With something like inhibition, there is no reliable general procedure for doing it, right? You have to kind of, because for instance, take an obvious example would be an example where the right answer is obvious. So suppose you have an ordinary graph rewriting system for undirected graphs, where there are two rewrite rules, one of which is planarity preserving, and the other of which operates on some non-planar tangle. Then, if you start an initial condition with a single non-planar tangle, and then that gets destroyed by some application of either of the two rewrites, then obviously the one that acts on the non-planar tangle can never be applied.
Yes.
But to determine that algorithmically is essentially a problem of automated theorem proving over rewriting systems, which is hard to do.
Yes.
So you could definitely imagine having a user-specified kind of inhibition function in the same way that we have user-specified decomposition functions or something, and place the burden on the person defining the multi-way system to
Sounds like that's what you have to do. Otherwise, it's undecidable, basically.
Right.
I mean, okay, but beyond,
that's only the causality is undecidable, right? The list of events that you can produce is decidable.
Oh, absolutely, yeah. Well, the list of events you can produce at any time step is
yeah.
It's the problem with inhibition with inhibitory causality is that in general it's a statement about infinite time limits.
my question is this. Okay, so absent the inhibitory thing, which is interesting, but I think still a herring far away.
I was only bringing that up in the context of there are, even in graph rewriting, there are many notions of causality people have developed, right? The physics project one is just one of the more straightforward ones.
Good. I mean, because it's like there's many notions of graph rewriting, which include very obscure things that, I just don't think, or dimension estimation and so on. There are lots of, I think, right. I think what we need, the goal here, just let's zoom out for a second. Part of the point here is in Wolfram language in general, we have single way, we have a single way rewriting system with a fairly arbitrary collection of choices that were made many, many years ago, which has worked really well. Our goal is to generalize that to the multi-computational case and to understand how you think about sort of language design in the multi-computational case, with the idea that that will also be relevant in modeling, et cetera, et cetera, et cetera. So the fact that we are making a somewhat arbitrary choice, a simple but arbitrary choice, I think that's inevitable. I think we have to make a choice. I mean, I'd just like to make sure we look around and see, is there another choice we could be making that would be better? And the big thing that concerns me is that, the compilation to hypergraphs is just a very different thing than we've ever thought about in the context of, Wolfram language or anything like it. The compilation to hypergraphs is a kind of, in a sense, it's a new idea in terms of what we're saying is tree structured expressions are not clear enough in terms of their causal structure for us to use those as the base for what we're doing if we're going to have causal information. Is that a fair statement? I mean, could this all be mapped onto transformations on trees? Or is it fundamentally not able to, does that have all of this weird, tree-like separation, loop back, link, thingies that happen where it isn't clear how you do the causality? Nick?
This compilation is pretty straightforward if you actually think when each of the sub-expression in a tree has its own address. So if you have a very low level representation of a tree and you replace part of it, you have a pretty straightforward definition of what actually happened and where in memory, right? And that's what those links are representing. So you can see what we've been destroyed and what was created as just some modification of memory, right?
Okay, so let me just understand. So Ian, for example, if you were to take the tree data structure and we were to say, can we turn that tree data structure? What will be involved? Maybe Nick already has things like this. I mean, just the very straightforward thing. I've got, a random tree. Okay, there's a random tree. Turn this into a hypergraph. What do I do?
Can we look at like a much smaller tree?
Sure.
I don't yet understand myself what this compilation of hypergraph into hypergraphs looks like.
Okay, Nick, minimal case. What do you have functions? Well,
yeah,
functions run, but
to link hypergraph, just run it on this.
I mean, do we think it's actually going to work, or?
Well, old version is the same as the new one. You just had a problem installing.
Okay. So, can we draw this as a tree? What is this to make this?
Can you explain like what do these links mean?
So the first element is just basically hyper-edge index. So it's not important. If we had some actual address of each of those, it would be the same. Then it's a payload, and every subsequent vertex is just a link to another hyper-edge. So just a linked thing.
Right. What it's doing is, in our language,
compound expression.
What's that?
What does this do if the head is a compound expression? Like replace G with G of 1.
It will do the construct thing.
I think the way to think about this is as follows. In this tree, in standard Wolfram language, we are absolutely hiding the fact that there is a pointer in the middle of this. This is really f of, this is saying f is applied to this pointer, and that pointer, which I'm not going to type the same, is g of x.
Right. So one question is this, to use an obscure way of saying it, is this running share? So I mean, is it actually doing the subtree isomorphism stuff to make this meaningful? Like where all instances of g of x will be the same hyper edge?
Yeah, that's a good question. What's the answer, Nick?
I think I understood the question.
Okay, let me show you. We can make a version of this. Okay, so if I say g of x,
Okay. Oh, you're just gonna point to the same thing.
No. No, what Christopher is asking is, those two g of x's could be the same, right? Those g of x's could actually be the same piece of memory, or not, as the case may be. I mean, that is not defined in, this question. Here, let me just save.
Well, and it's sort of important because I assume that the way that you do, when you apply a transformation, you get a new expression back that you then have to do basically it's essentially the subtree isomorphism stuff to say, where does does the g of x in the input expression appear somewhere in the output expression? But that question is only meaningful if all the g of x's in the input expression are, considered the same.
No, wait a second, Christopher. There are two different cases here. Okay, this is where there are giant can of worms. Okay, if this was a piece of space, so to speak, is it in fact the same piece of space because they're both g of x?
Right, and then the question is over time. But the point is, I'm saying these are related things because I'm assuming, maybe there's a different scheme, but I'm assuming that the way that you associate g of x from step one with g of x at step two is that you do sort of, you look, oh, does g of x appear in step two? And if it does, then you sort of say this is the same g of x. But if you had multiple g of x's in the input at step one, then it's not really meaningful to say, well, which g of x turned into the g of x in step two.
Indeed, what Nick is doing is he's saying these g of x's are really different. Here, this one involves links 2 and 3. This one involves links 4 and 5. So the fact that those things are both called g of x is irrelevant to Nick. He's using their position in the original expression to determine what their sort of what their hypergraph addresses are. Right, Nick?
Right. In this case, yes, but I can imagine they can share the piece of hyperedge, piece of memory. Then just all the replacement on those hypergraphs should take this into account.
Well, I understand that, but so we don't have a notation. I mean, right now, if you say g of x, I mean, it is deeply not something we're talking about. Whether those two 7s probably are shared. Those g of x's are not shared. The x's are shared, right? Because they both point to the symbol table. They point to a common place in the symbol table. But the g of x's, those are different pieces of memory.
Yeah.
And so when
the question is, do you run share?
Yeah, right. When are things different? And this is like, in our discussion of eames, it's like, are these the same eame or are they different eames? These things. And I think Nick is assuming that the structure of the expression defines the sort of emic structure and that they're different, which is fine, but we may need a notation to say these things should be treated as the same. But
in fact, I've been showing this with my lazy expression. Remember when I can create one lazy expression, and if I use it twice in the next one, it's going to share the same link.
Which is yes, but that's horrifying in various ways. I mean, in other words, look, are things auto-shared or not? And if they are auto-shared, over what is the scope of the auto-sharing? See what I'm saying? I mean, in other words, if the thing, and that relates again to these questions that come up in the physics project about causal edges joining things at different time steps and all kinds of funky stuff. I mean,
I put an example in chat. Can we see what the output is? Yeah, I feel like this structure is ambiguous.
why?
It's not clear if construct refers to a literal symbol in the expression or when you're just using it to denote. I feel like you're using two different expression tree structures depending on whether the head is atomic or not.
Well, yeah.
You can see if all the heads are
depends on-
atomic, then you just say F links to G, links to X and Y.
You're saying I can spoof this thing by basically giving something where I'm going to create a construct.
Yeah,
I have no
it's
idea.
like writing the expression as if it used a literal construct.
Yeah, I bet you're right. I bet you're
I-
right.
I think maybe the right thing to do would be to just always use this
Which?
syntax instead the out of 17 as opposed to like out of 13.
Well, that's not going to work. It's going to be too messy. I mean, I think the more plausible thing to do is to have something where instead of using construct to deal with this case here, there is some new token that represents a sub-value, a headdress type thing.
I still don't understand. The reconstruction always reconstruct the original expression. That's the only requirement. So like as soon as you fold the links and reconstruct the original tree, it just should reproduce the same one.
My point is that sometimes you
construct-
link the head to the arguments, and then other times you link the whole expression to the head and the arguments, which are two different things.
My suspicion, but I don't think that this is a point. I mean, I get this. Okay, my suspicion is that you really need something which is, look, construct could perfectly well take this, presumably, and do that. Well, actually, yeah, I don't see what's wrong with that.
I think the only
So do
difference
you
is
see, like in out of 13, F is linked to G, right?
Yeah.
Yes.
But in out of 17, F of 1 is not linked to G in any way. It's the outer construct that's linked to them.
The 6 here.
Well,
why is that a
you
problem?
see, the F is now a leaf. It never gets linked to anything. You have 3, F.
I see. Well, I don't completely understand whether that's a problem. I mean, Nick is making the statement, if you can reconstruct the expression from the hypergraph, then you're good.
Yeah, and the only difference is construct version requires evaluation.
Yeah, I suspect Ian is right that there's something a bit fishy here. I'm not sure this is let's not drive that. Let's pin this as an issue.
Yeah, I think I get the thing now, so I think my question's been answered. Thanks.
Okay, but so the model that we're using is, the thing is, okay, and what's the relationship between, okay, so in Ian's trace graph, okay, what's a good minimal example of trace graph? What's a good function to put in here to
Do
show
like
trace?
1 plus 2 times 3.
That's not very good. What's a well, whatever this is doing, that seems better. Okay, my question here is, one of our goals is to make this multi-way, and my question is that doable with expressions here, or do we have to compile them to hypergraphs? In which case, we've got a whole different level of complexity in these things here. Comments from Nick and Ian.
Well,
Yeah, I think
every kind of evaluation were just replacing graph replacement or expression replacement, then it can be possible. But it's not the only kind of evaluation that's there.
That's where? That's in this picture.
In general, as soon as you step away from just rewriting, you kind of toast. As soon as you want to run some kernel thing that's calling a library and so on, it's easy when you're just rewriting stuff. Then you
No,
can
I know. So I mean, but look, what do you mean? So you're saying if you're just rewriting, you could as well use hypergraphs or tree expressions. Is that correct? Is that what you're saying? But you're saying, what are you saying? Can you clarify?
Yeah, it doesn't matter what kind of object you're replacing. It's just hypergraph only provides a more convenient causal information. Or if you actually do it in memory, if you record the access to memory, then you can recover some causality from there. But there's no really difference.
I have a question. In the hypergraph compilation, does it become easy in practice to do distributed computation on those things? Is that plausible or is that absolutely hopeless?
It's just when you say distributed computation isn't usually.
Well, I mean, you put it in different processes. I think it's difficult because you're using a subset type thing, right? Where you're taking this whole vat of hyperedges and you're trying to find, two that you can pair together and rewrite, which doesn't sound like a very distributable kind of operation. Right? It's not something where you can say, I'll take this block of hyperedges and run them on one processor, another block and run it on another processor. Am I right?
Well, right. Well, it depends. Maybe you have some way of matching a tuple or subset in parallel. You can just run one thread searching for a first element, another one for a second. Something like that.
Maybe. But I mean, they're still going to have shared memory. It's not the case that, I mean, if we have a list, for example, a standard array type list, and we're doing an operation, or the same operation, mapping across that list, all those different list elements could be in different processors with different memory, and we can be operating on them separately. Whereas if we compile that, if we say, whatever it is, what was it called? Hypergraph to
two linked hypergraph.
Okay. If we do this and we say 1, 2, 3, 4, well, actually, let's do A, B, C, D. Actually, I'm curious what happens if I say 1, 2, 3, 4 in your code. How does it know what's what?
Well, the payload is just a second element, so just distinguished by position, whether it's a link or a payload.
Does that always work?
Why not? Yeah.
So links are always at the beginning and end, and payloads are in the middle.
The second one element.
No, they're not. They're not the second element. Look.
Well, the payload is the second element.
Because you can have more than one outgoing link.
What about that?
Oh yeah, payload is the second element. The first is the link of the hyperedge, and everything else is linking to other hyperedges.
Okay. But okay, fine. Let's see, where are we going with this? I was just making the point that the ABCD is easy to parallelize. It is not obvious to me that without sort of complicated graph analysis, that the hypergraph version of this is similarly has any hope of parallelization without significant analysis. Just making the point. Okay, so can we go on and
I think it should be possible to convert any DAG into a hypergraph the same way that you're doing this with expressions.
Yeah, you can even use a graph, a literal graph with
Does that already work?
yeah.
Like do linked hypergraph of
How do I make a DAG?
DAG.
Random graph directed edges goes to true.
Oh, does it work on any graph?
Well, I think so.
Okay.
I'm not sure
What
about
do I do? Now what do I do? What do I say here?
the same thing to linked hypergraph. This thing. %.
That's great.
Okay.
So you should be able to feed in the output of, in principle, feed in the output of trace graph into this and get the causal information.
Is that right?
I'm not sure how
Trace
that.
graph's a DAG.
Well, the causal information comes when you actually rewriting it. We're not rewriting the trace graph.
Right. It's like the edges in the trace graph aren't necessarily rewriting rules. They're like subsidiary evaluations.
I know, and that's where it's going to
They
get
still
really complicated.
represent links.
Right. Okay. Let's. Okay. Can we go back to the original thing? Nick, I mean, I just want to see your original multi-way. Okay, how do I do a basic multi-way, my favorite numerical multi-way system? Remind me how to do it in your framework.
We'll just give it the
Just
same
tell
way.
me the function. What function?
The multi-way object.
Okay, then what do I say?
A list of rules and initial condition.
Okay, so the rules are
X goes to something. X plus 1.
Do I do
And
this?
Yeah, and X goes to 2 times X.
Do I have
No,
to do it before?
then just ask for property.
Okay, so that's a multi-way object of unknown. You know, it's a lazy multi-way object, right?
Yeah, it just stores the rules. It already
Okay.
compiled them to the hypergraph rules.
Okay, all right, fine. So now in here, how do I, okay, so let's say I want to make the states graph of this.
You just ask the states graph property and give it number of steps.
But this is still quite slow. Is that a true statement?
Yeah,
Oh.
it is.
Unbelievably slow here. What can we do to make it faster? Well, this is ridiculous. Is this real? I mean, is this what's happening here? Is this broken?
I'm not sure.
Seems to be uninterruptedly slow. Okay, but that should work. Now, can you also make a causal graph from this? Oh, for goodness sake, I think it crashed. So what do I do here? I say, do I have to run something here? I have to say,
This the install still doesn't work.
let's try it.
Oh, I still have URL issues. I can't upload a Packlet for some reason anymore.
Okay, so Tracy, did you track that down?
I emailed Todd. I haven't heard back from him yet. I
That's
can
not
ping
going to be
him.
good enough. Yeah, we need to actually find the answer, and if necessary, ask. I mean, is the Packlet repository up? We could ask Connor as well. He might know.
I'll find out.
Okay, we kind of need an actual answer. Okay, so this is just saying can't get this thing. So how do I re-enable this?
Well, if you already removed the Packlet, then there's no way.
Okay, so really, I'm debugging this. Okay, what anybody know the let's get Todd here, please. Come on,
I'll let him know.
or Connor. Okay, what's the URL for the Packlet repository?
For this particular Packlet or in general.
No, in general. I'm trying to understand whether the Packlet. I mean, you deployed it to the Packlet repository, correct?
Yeah, sure. I tested it prior to this meeting.
Right,
The
but
whole
this is
my public call. This is
Okay.
the Packlet repository.
okay. So here, will your Packlet show up on this?
Should be. It was there.
Well, it's not here. What's the name of the Packlet?
Hold on, can you? I don't know why it's not there, but the link.
Right, so it's not there. So that's why it's not working, because it's just not there. Okay, so do you have a privately deployed version of this Packlet? Could you deploy it, and then can you deploy it privately? Then I can load it from that.
Oh, I'm trying. That's what I've been.
It's not working.
Yeah.
Well, this is no good. So
Hello.
Tracy, hi. Okay, is the Packlet repository just down or dead?
I mean, not as far as I know. I haven't heard
Okay,
anything.
so we're trying to debug something where really this is supposed to be a meeting about something completely different. Nick has a Packlet which apparently, I mean,
So there is a bug that's going to be fixed very soon with the Packlet site file. It's delayed updating around the time, within a couple hours after a Packlet is published. So is this published in the last few hours or sometime today?
Yeah.
Yeah, wrap that in a resource function. So you have Packlet install of resource function of the
resource function.
or sorry, resource object. I'm sorry.
Of this.
Actually, I was looking at the subsequent command, but
Well, what should I be doing? Is this the right thing? Oh, look at that. What do you know? Well, now let me try running this. Miraculous. Okay.
Well, wait, did you restart the kernel though? Because sometimes running get twice breaks things.
I didn't restart it. Do you think I need to? Well,
No, it shouldn't break things. Try this token Venn graph. Oh yeah.
yeah, okay. And let's see whether this other thing works over here.
Maybe try for the fewer steps. Still not sure what it's doing.
Crazy.
It's doing something weird.
Oh, this is oh, it's not merging at all.
Yeah. That's the point of my properties. It's not merging by default.
But that's crazy. We can't, I mean, we've used states graph for the last 3 years to mean a merged states graph. So we can't change that. Right.
Okay, I can change the default, but you can change
Connor,
it by.
thank you for your help. I think we got what we needed from you.
you're welcome. I'll note though that Packlet install command of the raw, I think you have in your other notebook, the string, you'll want to wrap that in resource function too if you use it.
Okay.
Yeah, you should be good to go. All right, thanks.
Thanks.
Bye.
Bye.
Thanks.
Okay, so what do I do if I deduplicating?
Its state canonical function goes to automatic.
Okay, so just so I understand, what that does is it takes any group. So if those were hypergraphs, okay, how do I get rid of all that crud? How do I get rid of
That's the next step in the agenda. Usually when you get the graph after duplication, you want to count the multiplicities. So we made a W of R that makes a simple graph and assigns weights.
Look, this is crazy. This is way too slow. It's just not useful. I mean, it's got to be faster. Right? It's completely unuseful to do this. I mean, it's amusing, but it's not useful. Right? Okay, so I'm sorry. So the point of the state,
what you do.
canonical function is, if they were hypergraphs, you were determining which of the various isomorphic presentations of that hypergraph you're going to use. Is that correct?
Yeah. By default, it's just hyperedges. When you do it automatic, now it converts them to some canonical version of it.
No. I'm trying to understand. If this is a hypergraph rewriting multi-way system, okay? My understanding, what we've had before, which you're changing, is we've had a state equivalence function, right? Which determines whether, so Jonathan, there's a question for you. With a state equivalence function, it says these two states are equivalent, but which one does it actually use in making the multi-way graph?
Well, quite. I mean, state equivalence functions looking back were a bad idea. That's I like this approach. I like the canonicalization approach. Because
Fine.
yeah, exactly as you say, in situations where equivalence is non-trivial, like for hypergraphs, we essentially had to make an arbitrary decision. So in fact, when multi-way system handles the Wolfram model case, the state equivalence is separate from the canonicalization, which is kind of stupid. And the canonicalization just uses an inbuilt hypergraph canonicalizer.
Okay, fine. All right. Well, I agree. This seems
this is a much better solution.
Okay. So the name probably is not optimal. I think it should be probably a state canonicalization function, I would have thought, Nick.
Oh, maybe.
Argue for this name.
It's just shorter.
No, that's not a good argument. Because the problem is you don't know what it's doing.
Also, it's not the function that's canonical.
Right.
Canonical function makes it sound like it is.
Yeah. Okay.
It's all right. A little bit.
Best maybe you could have canonical state function. It's the function that gives you the canonical state.
Yes.
Yeah, that's better.
But again, my concern with it is you don't know how it parenthesizes, right?
No, I know. I think canonicalization is more clear.
Right. Okay. So now let's understand the event canonicalization function. So how do I indicate this? How do I show the events here as the bipartite type graph with the events shown? Nick.
It's evolution. The same as multi-way system, evolution causal graph.
Okay. But now notice that with these numbers, in the past, it wasn't very well defined what the causal dependence story was. So have you now clarified that? I mean, is what you're doing now clarifying that?
Yeah, it should. Now, well, the only difference is you don't actually evaluate the right-hand side. It's always structural. I'm thinking of some kind of property, but that evaluated, but you're gonna lose all the causal information. So you don't actually multiply by 2, add 1.
Okay, so let's watch this because we're going to see this right here. Right? Can I put graph features in here? Can I put graph?
Yeah, you can.
Okay, so what we're seeing here is there's an event. This is very weird looking. This says, what the heck is this really doing? This is saying, explain this thing to me here. 1, 2 plus 1.
Oh, it's the same kind of format as the string multi-way system for events it's using. You have one that was an input on the top. And the one
I see. This already had the +1.
Yeah.
Oh, I see. That was no. Yeah, go ahead.
Well, the state, because you use the state canonical function, evaluated the 2, right? So,
If
but
I
events
got rid of the state canonical function,
original. Yeah. Maybe it's still kind of.
I don't understand this. I don't understand. We've got a 2 here. Why are we still seeing the 1 up here in that event?
I'm not sure. Maybe evaluated also converted in the vertex shape function, but the actual state is also some kind of plus. on your left branch and times on the right branch.
What? I mean, I don't understand. This state, to get from this 1 to this 2, I mean, this seems completely wrong. I mean, this should say here 1 plus 1 or 2 times 1, right?
Yeah, I agree. It should say that, and it's actually underneath. If you like ask for vertex list or something, I'm pretty sure that it's going to be a hypergraph that corresponds to this expression, like 1 plus 1. It's just I'm doing something weird. And
Okay, all right. So it's a bug. Okay, fine. So, okay, so this is the most minimal, uncanonicalized version of things, right? We didn't canonicalize anything here. Now, if we say event canonicalization function here, that didn't change anything for this. Perhaps it just doesn't change anything in this case.
No, maybe, I think it did. There's at least 2 events that have mergers now.
Oh, yeah, right. This one here, right, merged. Okay, so what happened there? So that merged because...
Well, because
those events are the same. Those events are both 1 goes to 2 events. Even though they're not really both 1 goes to 2. One is 1 goes to 1 plus 1, and the other is 1 goes to 2 times 1.
Yeah, I think the default canonical for events, it only considers local thing. So if it writes the 1, that's the actual event. So like what is the yellow box showing is the global rendering of this event, but the event is local in a way that it only acts on subset of hyperedges or sub-expressions.
Yes, but then it's canonicalized when... Okay, so here, this is telling us this destroyed and created is based on those are the eames, basically. Is that right? Those are the elements of the hyperedges.
Yeah.
Is that correct?
No, yeah, the links, specifically the first elements in this particular.
Right, but in the physics context, those links will be atoms of space. Correct? Those link names are atoms of space, or in the more general case, atoms of existence or eames.
Mm-hmm.
Right? So what this is saying is, so this thing here is saying that event destroyed eam2. How could it create eam2? I thought these things were one single use objects.
No, if you, it will almost, I think it's always gonna recreate the same one, because there's no point to destroying it completely. You can, if you look at it as a memory, you can put in the same address this sub-expression again, right? The same eam to the same place. So if you destroy
but why isn't that eam just outright destroyed? I don't understand. I thought
in terms of the hypergraph, wasn't it the case that you destroyed the destroyed is like the outgoing link, and the created is the incoming link? Is that right?
No, it's the other way around. Destroyed is the incoming link. Created is right. Can we do the minimal case, Nick, please? What is the minimal case of this?
Well, something with strings, maybe.
Specifically,
just take the same string system on your from the agenda notebook, and maybe ask for just a one-step causal graph or something. We're missing M there in the beginning. Multi-way object.
what the heck is that?
Now there are 2 events. They're not causally connected to each other. You can include an initial event. Maybe it will be clear.
Initial what?
Event. Include initial event goes to true.
Okay, so that's the Big Bang. From nothing, we created AA.
Hmm.
And I don't understand. I'm sorry, I don't understand. Why
I
is
think
this
what's
saying it
confusing is
destroys?
that you don't see how the AA itself is represented as tokens.
Yeah. And I mean, so if you say two linked hypergraph of quotes AA, it looks like that. Okay.
Well, in the evolution causal graph, I think you're gonna have a tooltips for the states as a hypergraphs. Maybe
Okay. Fine. Let's look at that. But I don't understand. I don't understand. Why didn't it destroy the zero thing there? So which one? Evolution causal graph?
Well, yeah, it did destroy it. Actually, in this case, it didn't recreate it.
Okay, I don't have tooltips. I
essentially.
don't have tooltips for the multi-way for the hypergraphs here.
Okay, I don't know.
Okay, so let's take a look at. I simply don't understand this thing here. So
Right, but you see in out of 19, there's the 2 in both of those tokens.
yeah.
Oh, I
Isn't
know.
it the one is always created
know
and
what you
one
need
is
to do.
destroyed?
It's because I changed how the strings being replaced. Can you add method goes to none to the multi-way object so that it actually uses hypergraphs for strings? Not for the graph, for the actual object when you're creating one after the initial conditions. Method goes to none. So now the tooltip may.
It's not right. Okay, I don't understand this. I don't understand why, looking at this here, okay, it destroys the 2 because it's using the rule. What is it doing here? What is it doing?
Well, it destroys the one hyperedge, it makes 2 hyperedges.
No. That 2 index there that it says it's destroying is the
Yeah.
same EAM index as there. Is that correct?
Yeah, the same.
Okay. So what is it doing?
Maybe with a different payload.
No, but the 2 is the same 2, right?
Yes.
Okay, so this event is doing something to this state. This state is 1A2 to A0, correct? That state is this.
No, it's think it's 2 and 3. Because if you look at the initial event, it creates 2 and 3.
Okay, so this is 1A2 to A3, correct? Is this
Yeah, something like that. Yes.
Okay, all right, so then, okay, I do not understand this. I don't understand.
Why? It destroyed the link number 2, and because 3 is already taken, it creates a link number 4. It's a new one.
Yeah, I know, but why is it recreating link 2?
Because it can. There's no reason to not to reuse it. Absolutely no reason not to reuse it.
I don't agree with you. I think it's super confusing. I think the causality is super confused if you reuse it.
Especially when you just, if you want somehow explore what actual event did, if you always have created different links from the destroyed, you'll never know.
Okay, what is the causal relation between the incoming thing? What I was understanding is that the fact you're reusing that name, it is a different EAM, is it not? Or am I confused?
It's the same link. So it's the same EAM as a link, but it can change the payload. So payload changes. It's the second element of hyperedge.
Okay. Who else understands what's going on here?
I must say that I've never fully understood or even agreed with the notion that atoms of space can be destroyed or that EAMs can be destroyed. I mean, it seems as though you will have it can be some computation, it could be a multi-way structure. Okay, you're making use of certain EAMs. Okay, this structure has some span within the overall Roolead, let's say. And it can capture an EAM. We could say it could jettison an EAM, but I don't see how the computation itself has the power to bring EAMs into the Roolead or.
All right, so maybe the wording is wrong here.
No,
maybe
I think the wording is yes. I think the wording is correct.
destroyed. It should say consumed.
I like to think of them, I mean, the eames are there. I like to think of them as being captured and let go. I mean, I said jettison, but that,
Well,
that,
okay,
that
I
word's
mean-
probably not going to be.
Oh, they still can be
Popular.
destroyed. If your right hand side is shorter than left hand side, that im gonna be destroyed completely.
Well,
What does it mean destroyed?
a
I mean, it
local
depends on
local
time.
view, you could say kind of informally, local to whatever multi-way system that you're examining as kind of a somewhat semi-closed system. I guess you could say it's destroyed. Taking a structural view of the Rulliad, they're definitely not destroyed. They're just not being used in this particular multi-computation. And the creation of eames is a complicated thing that ultimately involves hypercomputation and the hierarchy of different Rulliads. So it's definitely not creating eames.
Well,
And once they're there, they're there. They're not getting destroyed by some particular hypergraph.
maybe it's
rewriting.
absorbed and emitted. I don't know.
Yes.
But I'm
Yes.
just trying to understand.
yeah.
Isn't it
that's-
incoming,
yes,
outgoing?
right. No, absorbed and emitted. This is a
Well,
good one.
Actually, incoming and outgoing is not bad because that is simply saying for this event, these are the incoming things, these are the outgoing things. Does Jonathan have an opinion about this?
I think that's too weak. I agree. Maybe created and destroyed is on the other hand too strong.
Yeah.
But the fact that, for instance, you can have outgoing tokens that inhibit all subsequent events for a particular computational scheme means that just describing it with a purely passive verb doesn't seem quite right.
Look, I think this inhibitory thing is a different overlay that I don't think we should get ourselves too confused by. I think it really is a major,
Yeah, but again, I just like before, what the point I'm making is nothing to do with inhibition. I'm just using that as an illustrative example.
Yeah. I have to say, say again what you think is wrong with incoming and outgoing.
What that, Jonathan, that is basically intransitive.
I mean, James, I didn't really understand your monologue. I may have to ask you about that later. But if we're using a passive verb like read, if you're using passive terminology like read, write, or incoming, outgoing, or whatever, then okay. Going back to the example I gave right at the beginning, right? You've got some rule that acts on a K5 subgraph or something, and you've just applied an event that's gotten rid of the only K5 subgraph that you had in your graph rewriting system.
Mm-hmm.
That is a fairly destructive process, right? It has a significant upstream effect on all subsequent event and causal structure. And therefore, just saying that a particular collection of tokens have been were incoming or have been read or something seems somehow too weak. But that's
yeah. Well, I mean, something comes in and it doesn't go. Okay. I have to say, from what I'm hearing, incoming, outgoing is the least confusing so far, but I might be wrong. But let's keep going here for a second, because what we're seeing is, okay, Nick, do you want to say, okay, what on earth is this tree position? Where's there a tree? I thought everything was turned
It's a
into
multi-way
hypergraph.
tree. No, it's a multi-way tree. Because your
I see,
events can be
this
branchly
tree.
connected.
You're saying before equivalence, somewhere up here, the thing was a genuine tree, right? This thing here was just a tree.
Yeah.
So everything that is not like that. Oh, I see. There we see the actual hypergraph version.
Mhm.
Everything that is not like that is not like that because of canonicalization. Were it not for canonicalization, it would all just be a tree. And maybe from the outside of the universe, everything that happens in our universe is just treeing out. And everything else is being pulled together by these canonicalization functions. Now, is that all we need here? We need the evolution function that says how to transform a state into multiple states, right? That's what we have here, correct? And then we need these canonicalization functions, equivalencing functions, correct?
Well, I'm not sure whether it's something else is needed. Depends on what you need.
Well, I don't know. You tell me. I mean, but to generate the multi-way graph, okay, what is token canonical function?
It's only for the token event graph. Because now your state, well, blue boxes is just the individual hyperedges. So it's just a little bit different. I couldn't name it the same way.
Sorry, I don't understand this. What are you saying here?
Well, token event graph, all it's doing is taking, for example, the evolution causal graph or something like that, and decomposes a state into tokens. Because everything is hypergraphs, it just decomposes it into hyperedges.
Right.
And if you canonicalize each individual hypergraph with its default type, like here it's a string, it's going to be just a character.
I'm a little confused. I mean, if we ask for the token event graph, one of the things we can do in a token event graph is to say that we have, pairs of things. We say something like x blank, y blank goes to x plus y, x minus y, for example, correct?
Yeah, maybe token event graph here is a bad property name. It should be that glocal thing.
Well, I don't understand. I don't understand. What does this do? Is this going to do something reasonable?
I don't think it's going to work.
Oh, but this should work, right? Because our standard token event graph function does work in this case, right?
Yeah, it works in this case, but
okay. But so this is just a bug, or this is something different?
Maybe it's a bug. Can you wrap one in one in additional list or something? Though I'm not sure.
Oh, that looks right. That looks right. That's the sort of scattering event. Okay. By the way, I mean, this is a physics question. I don't know if anybody, does this in fact generate the Feynman diagrams of 5/4 field theory? Anybody have an opinion? Jonathan, do you have an opinion about that? I think it must do. For a particular, if you have two incoming legs, this is combining these things in all possible ways, I think. Which kind of means there should be a formalism for working out, anyway, never mind. That was irrelevant, unless Jonathan wants to comment on that.
Well, I mean, yes, there is a formalism. Yeah, okay. This is a consequence of the fact that string diagrams and Feynman diagrams are equivalent for functorial field theories, and token, well, at least local multi-way systems are string diagrams, or interconvertible with string diagrams.
Let me understand that statement, because string diagram is also something we really want to okay, but these are not string diagrams. Is that true? Or these must be very close to string diagrams? I mean, a string diagram can take, okay, can somebody explain? Anybody know how this works?
So we want to treat tokens as some kind of types, system types in the string diagram, and your events are actual processes or boxes.
Mm-hmm.
Yeah, and all the edges are kind of wires, except the causal there. Causal edges doesn't mean anything in the string diagrams.
No, I understand. String diagrams don't have causal edges, so this would be a states graph, but with
after tokenization of each of the states. It's an evolution causal graph.
I don't understand. You said it doesn't have, but we have to break the things into tokens, right?
Yeah,
Which is the kind of local story.
Right.
So do we have a representation of that? That is essentially
anything that breaks into tokens. I only made for the token graph for now. That's the only thing that breaks things into tokens.
Okay, but this could break into tokens here.
Yeah.
So that's probably a good thing to have.
I wouldn't call it states graph, maybe just token graph or something.
Yeah, I think token graph would be a good name for it. And then, but that's what's happening here. If we got rid of the events, this is that token graph, correct?
It's weird because string diagrams, if you're getting rid of events, you're basically getting rid of the boxes. The main thing.
Yeah, so that can't work. So I mean, okay, this probably is
Well,
it's like I have it in the quantum framework, for example. We have if you have a circuit diagram with gates representing events, you can make a tensor network when each event is a gate, right? And you also can turn this tensor network in this basically when each gate is some kind of graph click. So you only have tensor indices. Those would be like tokens.
Okay, so those are names for the wires. You're saying tokens in that case are names.
Tokens are names for the wires, system types.
Yes. And how does that relate to string diagrams again? I mean, so are you saying this basically is a string diagram where these are the boxes and these are the named indices going into the boxes? Is that right? Or am I confused?
Oh yeah, basically it's just maybe string diagram also explicitly shows the ordering of how those wires are connected to the events. Which one is the first one, so on, the second.
But doesn't this show that too? Because it has arrows.
Well, it's kind of arbitrary, right? You don't know by just graph layout which one is the first one.
Why does it matter? So is there a tensor representation of this diagram here?
For the events, yeah, you can basically, what is the tensor representation of a string diagram? You turn every event here into a tensor, where each incoming state is a row, row index, and the output token would represent a column index.
Is that the analog of covariant and contravariant?
Yeah, covariant is the same way. Yeah.
Yeah, okay. So you're saying that this thing here could be written as a product of tensors, where the knitting together by virtue of these edges. So by the way, that's a place where it matters whether how the eames are named, how the tokens are named, right? Because in this case, that 2 better not be the same as this 2 here.
Well, it would just mean, if you equivalence them, it just mean an additional contraction.
I agree, but that contraction is not what we actually want for, I mean, that contraction, if we were writing this as tensors, this would be ijkl. And it better not be the case that this is iijj. You see what I'm saying?
Yeah, it actually is not a construction in terms of string diagrams. It's an additional event that has an output those the same thing.
Oh, I see. I see. The point is, what you're saying is these are not the hypergraph indices. These are the payload. Right. In fact, we can see the hypergraph indices there, and that's just the payload. Jonathan sent through something here. This looks exciting. It's lovely. He says, well, he says it's lovely that this stuff just runs. Okay. Wow. All right. What is this? I love your stuff, except that you have such a predilection for these boldface letters, which seem to me to make it more ugly than it needs to be. Anyway, a very minor point. Maybe at some moment we should spend a few minutes of design time on these. But go ahead, explain.
No. I wanted to get a concrete example of some tensor networks and show their relationship to function composition.
Can you explain here? So F, is that a composition or is that something different? No,
so
that's
the tensor is a parallel composition, right? So these are, okay, all right. high level point, of course, is that single way computation produces a category, multi-computation produces a monoidal category. The branchial graphs are then tensor products of tokens or states that lie on a single time slice. And then the edges that relate them are tensor products of the corresponding morphisms. This is demonstrating that explicitly for the case of an abstract category, right? So F and G here are functions. You could think of them as being like evolution events. X, Y, Z are essentially like tokens.
So what are these different things here? I mean, when you say G cross F here.
Yeah, so G tensor F, it's saying there are within the framework has a whole tensor, effectively has an internal tensor algebra subsystem. So it's showing within this framework what are all equivalent ways of representing that tensor product. It's taking every morphism, every tensor product morphism in the monoidal category, and it's decomposing it. So it's saying, so F here is a function from X to Y, and G is a function from Y to Z. And it's saying, okay, so there are three different ways we can represent G tensor F. It's either you take Y tensor X, you apply G tensor F, and you get Z tensor Y, or you take Y tensor X, you apply G tensor the identity on X, you get Z tensor X. Then you apply the identity on Z tensor F, and you get Z tensor Y. And that's the
hold on. I'm still deeply confused. There are a certain set of relations here.
Mm-hmm.
What's the actual input that you are doing something to here? I mean, there are relations that you're applying, but what are these being relations applied to an input?
No, so this is in a sense, or in a way, you can think of it as being relations applied to all possible inputs, because it's the strict monoidal category that's freely generated by that quiver.
Okay, can you relate this? Okay, can you relate this to like this? Do you have an analog of this diagram here in the category, in this categorical? Okay.
Well, I mean, every concrete quiver is effectively a global multi-way system. And there the events are the boxes, the tokens are the wires, and then the tensor product structure is the way you construct branchial graphs.
And what are the triangles?
Those triangles are identities. Those are identity morphisms. So
they're just like boxes, but they're boxes that just go straight through.
Yeah, exactly. So that's actually there are a few different ways people have notated string diagrams over the years. I'm using the one that's closest to Penrose graphical notation.
Okay.
So in graphical notation, that would be an identity.
And so this here is a 2-to-2 event.
Yeah. So that's a rank 4 tensor with 2 contravariant, 2 covariant indices, if you want to think about that way.
I'm sorry, the tensor product, your statement that a branchial graph, why isn't the whole graph here a tensor product? Why are you saying only the branchial graph is a tensor product?
Well, you can't take a tensor product of a state and an event, right? Just as if you think about whatever ordinary tensor calculus, you can take tensor products of a Hilbert space with a Hilbert space, or a matrix with a linear transformation with a linear transformation. You can't take a tensor product of a Hilbert space with a linear transformation.
But my understanding is this is like a tensor with indices ijkl.
Yep, exactly.
And it is pluggable. Oh, you're saying this has to be an X that plugs into another thing that has an X on it. Is that right?
Yeah, I mean, well, you can see some plugins. Like, I mean, this is why I sent the example, right? If you scroll down, so here's some slightly more non-trivial plumbing, right? So big F takes in an X tensor X and outputs a Y tensor Y, and big G takes a Y tensor Y and outputs a Z tensor Z.
If I'm trying to understand these in terms of tensor indices, are these like typed tensor indices or something of type X, Y, Z or something? That is, in naive tensor indices, this I would assume would be, F, Ij, Kk, if I'm understanding correctly. And this would be G, Kk, Lm or something. Or am I wrong?
Yeah, in the sense that, yes. So with the Kk representing the fact that these are the function. thinking about tensors as being a formalism for, you know, multi-argument, multi-value functions, that they're, you know, what you're the KK is indicating that it has two values, but they're the same.
Yes. But now, is it the case that if I want to plug things onto the X here, that that I can only plug an X onto an X? Is that true? Or am I confused there? This is not a dummy X. This is an actual X of some kind.
In the sense that the function big F will only evaluate if it's fed an X tensor X.
Yeah, where it's actually X. It's not dummy X. It's the object X.
Yep.
Right. So, right, but that's not like ordinary tensors, Tijkl. It's like you can plug the I into any index of any tensor. The I could contract against any index of any tensor. There's no type information about the I.
Well, it's more like with ordinary tensor calculus, the identity of the box would change if you fed it a different thing. Right. If you think about this again, if you think about it in the ordinary tensor calculus case, where you've got, you know, these are Hilbert spaces and linear transformations, then if you feed it a different, you know, if you take your linear transformation, you feed it a different vector space in this left-hand side of the tensor product or something, then it's a different linear transformation.
I understand. Hey, Nick, how do I make this work? Does this need this resource object thing again?
Oh, well, let's hope. I tried it myself. It worked without it. Okay, forget it.
Can you show this on your screen?
Yes. It's a simple tensor network for this circuit. When you have, and it's index representation, just to make it a little bit clearer.
Okay, show the circuit again for a second. Can you show the circuit?
Yeah. So you have H and one C node, which is two input, two output tensor, basically.
What is the H doing for us here? It's just it's the analog of it's a one-to-one thing. Is that right? Just taking one input wire and giving out one output wire.
Yeah, right. And this is like a representation of a tensor network when you only have an indices. And when you have like very high rank one, you make a complete graph out of it, like a clique. So this is like a complete graph that represents this 4-rank tensor. And all the indices are connected when they're contracted together. So if you want to evaluate a circuit, you just contract all the corresponding indices, all the edges.
Am I correctly understanding, Jonathan, categories, this quantum thing, the multi-way inspired token event graphs and so on, these are all the same. Is that right? I mean, these are all basically interconvertible formalisms. Is that a true statement?
Yeah.
And so in a sense, that makes us want to design, from a language design point of view, wants us want to make, it's just like we could have said, oh, we've got algebraic expressions and we've got graphics objects and we've got this and we've got that. But in fact, we can represent them all as tree-structured symbolic expressions. So I guess what I'm looking for is the grand unification between all these things. And maybe you guys have already figured this out. But what is the kind of grand unified, just like a notebook is an expression that is a tree-structured expression, just like an algebraic expression and so on. What is the common representation that one day could be the foundation for all of these things which are ultimately equivalent? Did that question make sense?
Yeah, and my view. So
what? No, I did, Jonathan. Assume I know nothing. What is your view?
Well, concrete categories are the way to think about this, right? That's the reason why this correspondence exists.
Okay, but explain. Maybe we should go back to my screen for a second here, and I'm unfortunately going to have to leave soon. But Okay, but okay. So this is what, okay, this is an abstract category. So that is explain that statement. I mean, in other words, I understand, but what we're trying to do is make a minimal. The thing is that somehow this looks very declarative, which perhaps, I don't know. I mean, do we think there's a language design to be made directly out of this? Or do we think that this is a more mathematical formalism that potentially sits on top of a raw, symbolic expression language design? I mean, it's like, you could do language design in which polynomials are a fundamental thing, but you wouldn't do that. I mean, the big mileage, I mean, look, historically, boring historical point. Before SMP, basically, all computer algebra was done by people who said, we've got a representation for polynomials. We've got a representation for, vectors. We've got a representation for this and that. Okay, the big point in SMP in particular was actually all of these things can be represented as tree-structured symbolic expressions. So I guess the question that I'm looking for here is, what is the analogous, and everything can be thought of as a this, and this is as easy to understand as possible. And are you saying that categories are the this in that sort of sentence, or are you saying categories are a formalism that allows you, that is a way to think about it, but is not it itself?
I don't know. It depends on how natural you think sequential and parallel function composition is as an idea. I think it's extremely natural, but
no, that is a natural idea, but I don't think it's represented in, I think category theory. Okay, so again, with the way Nick is doing this, okay, look, we all agree that, I think, that there is an evolution function and there is equivalencing or canonicalization functions. Is that what you're also saying here, Jonathan?
Well, yeah. I mean, like I said, the way I've designed this is that, so at least in my formulation of this stuff, which I mean, Nick's code, both for the multi-way system framework and for the quantum framework, I think has diverged from mine now quite significantly. But so local multi-way systems and concrete quivers are trivially interconvertible in that system.
Mm-hmm.
And both of them are interconvertible with linear transformations of Hilbert spaces, which is what the quantum stuff is about.
All right, we have a magnificent grand unification, which is so close but not quite there, in my opinion. I mean, it's like, but what you're doing here with this, Jonathan, with this category theory stuff, which is great, is there's a whole literature about category theory, and it's like this is the bridge to all of that stuff.
I'm not even, I should be clear, I'm not even particularly trying to to push category theory. I'm just saying it's useful to actually have unification between these functions. And
yeah, for sure. But that's what I'm saying, is that I think, okay, again, I am pretty sure, and we're so close here, I'm pretty sure there's a way to think about all these things. The thing that is really clean about tree-structured symbolic expressions and pattern transformations between them, it's very simple. It's very easy to explain. Right. And we're getting close to that with all of this, but we're not quite there yet. As all of us get confused about what's a token and what's this and that and so on. Right? Sorry, go ahead. And then.
Yeah, but again, okay, I'll make this point one last time because it keeps getting dismissed, but I do think it's an important one. That it's the way that tokens get composed and ingested into events is kind of the core of what makes multicomputation complicated, right? So, and in particular, the thing I like about the global multi-way representation, and probably which is also true with the token event graph representation as well, is that in effect, all systems can, you've essentially got two tensor product structures, right? You've got tensor products of tokens in space, and you've got tensor products of tokens in across branches.
Mm-hmm.
And the tensor product of tokens across branches is necessarily commutative. And all multi-way systems can be, all computational systems can be divided up into one of two cases. Either the spatial composition is commutative, as it is for hypergraphs, or it's not commutative, as it is for, say, Turing machines or expressions. Right? And that distinction, essentially between whether the category is monoidal or symmetric monoidal, if you want to phrase it that way, is the reason, I think, for a lot of these confusions about, are tokens really being destroyed, or are they just being referenced or whatever? Because in that case, it matters. The algebraic property of how tokens compose in space actually matters.
Right. I mean, look, my suspicion would be if there's a choice between, it could be commutative or it could not be, that the general case is going to be it's not commutative. But that may be, because if you think about sort of symbolic transformations for symbolic expressions, and I really have to run in a second here, but if you think about that, it's very general. There's no immediate kind of, there's no immediate, and this thing is commutative even though it doesn't have to be type thing. Okay, I unfortunately have to go, but we need to continue this. This is great. We're really getting somewhere, in my opinion, despite small technical glitches and so on. Good stuff. All right, I've got to run. Sorry. See you all later. Bye.